Hi, this is Nathan Tinsel. In this Learning Goal video, we will talk about how to make a four-part conclusion to a test comparing two group proportions. We'll use the Swimming with Dolphins dataset to talk about this learning goal. Remember the four pillars of inference. First, significance, getting a p-value, assessing strength of evidence. Second, estimation, getting a confidence interval for an unknown parameter value. Third, can I generalize? Did I take a random sample? And fourth, is cause and effect possible? Did I do a randomized experiment? You can and should answer these four questions about nearly every study from here on out in the course. Let's see how this works on the Swimming with Dolphins data. First, significance. The p-value here is approximately 0.02. This means we have strong evidence that the probability of someone having substantial improvement on depression symptoms is higher when swimming with dolphins than in the control group. Next, estimation. Compute a confidence interval and interpret it. Individuals who swim with dolphins are between 0.091 and 0.843 more likely to show substantial improvement than the control group. That's at the 95% confidence level. Third, generalizability. The participants here were volunteers, so it's not a random sample. So we should be cautious when we try to generalize this result to a broader population of depressed individuals. We really need more information about the characteristics of these volunteers to understand to whom we may be able to generalize this conclusion. And finally, causation. Random assignment was used in this study, so the significant difference in proportions of improvement can be stated as likely being caused by the presence of the dolphins due to random assignment. Now, this assumes that the control group was treated identically except for the presence of dolphins when swimming in the ocean. A couple of words of caution. There's a few different randoms going on here. Let's try to pull those apart. There's random assignment, random sampling, and random chance. Random sampling is how did you get the sample? In this case, how did we get the 30 people into our study? Well, they volunteered, so we didn't have a random sample. That fact allows us, or not, to generalize to the population. In this case, we need to generalize with caution. Second, random assignment. This is after you have your subjects, in this case the 30 volunteers, what do we do with them? Well, how do we put them into groups? In this case, we randomly assign them into one of two groups. This random assignment allows us to minimize the potential impact of confounding variables, leading to a potential cause and effect conclusion. Here we do have random assignment, and so cause and effect conclusions are possible. And finally, random chance. This is what we model in the simulation. In this case, we have a small p-value. This means we have strong evidence against random chance as an explanation for the observed statistic. So, three different kinds of random, each with very different implications. So make sure you pay close attention to the word following the word random.